let's take this guy. So this was probably one of my first designs when I started with OpenSCAD to learn how to use it. So this is just a basic thin box where I'm extruding through the text of our family name, and when you compare it, so as you can see, we just had our 20th anniversary, which is why I made a lot of little things to print. But this is what makes it. So I can move my cursor, move the model around over here, but there's nothing over here to create anything. That all comes from this code.
So this is more just visualizing what you're doing.
This is just running the code that I have over here. So if I go in here and I change something, well, let me see. What can you change?
Is it quick, or do you have to do like a compilation step?
Both options go there, right? So let's call this Smith, right? Oops. And I go up there and say go, it's Smith. Now, in order for me to get this to an STL, I have to render it first, because it does do some calculations of some measures that it needs to go up so it can actually optimize the object correctly and knows exactly how each layer interacts. And depending on how complex the model is, that may be a lot of calculations, or it may be a little. So now it's done, and now I can hit export to STL, and I'll get the STL file out of this object to get ready for the slicing. And that's the basic premise of this. So there's a whole, oh, I'm not connected right now. I didn't actually think I needed to do that. So anyway, everything in here is documented, and this cheat sheet I probably go to every time I use it. It has all the main commands, but there's a lot of libraries out there that are just available to do certain complex figures or settings, just like any other programming language that can do a lot of stuff for you out of the box. So you include those, and you're basically off and set. It is exactly like you see programming. It has for loops, it has if statements, it has everything that you want to do in a programming language.
Do they have their own programming language, or is that?
It's their own matter. It is based on something, but yeah, this is not a typical programming language that you would know otherwise.
Does it support object-oriented stuff?
Object-oriented
Stuff?
No, this is not. It's not an OOP type of language. It is basically a traditional structured language, but it does support recursive and all those kind of
stuff.
funky stuff. There is an example that is recursive. Let's see if I actually have it. There we go, recursion.
So all those numbers that are in there, Peter, like 47, comma 20, do you have to figure those out by hand, or? Okay.
Well, you can make the functions to calculate them, right? So here's an example of a recursive function that. So you basically don't know what needs to be printed. It will come up to figure out what the text is to be. And here's the function that calculates what the factor of 6 is, which is a recursive. This is typical programming 101, right? That's one of the first functions we ever created. But so you can do this, and it will actually come out with the results that you need to do this stuff. And now that I actually have internet, I can go to the cheat sheet, I hope.
Now that model right there where it says 6 factorial equals 720, is it going to actually put a back to that, or is it just going to print those like individual letters and numbers and things?
That I didn't understand. I'm sorry.
Like, is it going to just print an equal sign, a 7, a 2?
It's going to print these objects. I mean, a 6 and an exclamation point.
So there's going to all be individual objects. They're
Yeah.
not going to be like,
If they're not together like anything else, this is the object. And in this case here, as you can see, they're flat. I didn't extrude them, so this would not print very well. If I don't give them a mass, and it's kind of like. I can see them on the screen because they cheated in this universe because it's two-dimensional, and I shouldn't be able to see them in a three-dimensional universe, but they do that so I can debug it. But without extruding them, I can't print them.
and if you don't put a base behind them, they're just going to.
No, you can make them individual. I mean, if I print this, I'll get 6 objects. I printed, but then I can move them around. That may not be what I want to do, right? But as you can see, all I need to do is to go in here and change. Let's say 6 to 8, and I hit, it should be a 5, but I don't know. Oops, I did a programming mistake. Sorry. There we go. Right. So it's just a programming language. I'll do whatever I want. So often when I do, so this is what you then can, instead of looking at your boxes, I want to circle there and there. You start looking at it in relative perspectives to each other and say, well, this needs to be X percentages shifted over there, and this needs to be shifted over there, and if I need to have a certain distance, I need to make sure I calculate what that needs to be from the center point. That's the way you're going to design your objects, but it's going to follow those programming constraints you set up. And you could say, if I have a box that is this big, then the distance between these two holes needs to be that long, so they, they match what they match. So you can make it pretty stable, and there are lots of parameterized versions of these that basically says, give me the dimensions of the box, give me how many holes you want, what type of holes they want, and it will calculate everything else for you and set them up. So from a programmer's perspective, this is a great tool, but I'm finding personally that abstracting something I'm trying to design into a programming, that's not really what, in some cases, how my mind works. I got to look at the object and see, particularly if I have multiple things that have to work together. This is going to be tough. Like if I want to make two gears that have to interact, this is not necessarily the best type of object programming to do that for. Right? To make sure they actually match and can rotate. But we have better options for that. Oh, that's not the one I want. Beat that. So this comes up empty because I don't use it on this machine, so I had to install it. But the way we get started with FreeCAD is in the part designer. And we'll create a sketch, and this gets to be a little bit tricky, but you start out by creating a two-dimensional object. And it's basically asking what plane is that object, so when you extrude it, you know whether it's going to get wider or higher or stuff like that. So when you start creating stuff, we basically go in with we start with a line. So we have a line from here to here. We have a line from here to here. Maybe a line from here to there. And let's do an arc. A circle there. There we go. And I don't know. I gotta figure out something. There. And I go up there. So let's say I want to make something looking like that. I don't care. But what you're going to see up here is you're going to say, oh, this is way under constraint. I don't know how wide, far, whatever everything is in here. So you got to tell me some more about this world that you have. So what I can start. Oops, it's still one mode. So I start going by saying to it that these two lines, for instance, I want them parallel. And now I need my bigger screen. Wow, how do I move these? So my setup at home is much bigger than this one. So now they're parallel, so they will always be parallel. So if I can move this, but if I start to move this, I can't change the angle of this without having the other one falling on. I also want to say that these 2 points are the same point. Oops. Didn't I select them both? I'm good at that. So they use these colors, and I cannot figure out whether I select them or I don't select. They have to be green, I think.
They're both green.
But they're not selecting them correctly. That's why then. Let me just do this one. It's supposed to merge them, it doesn't. This is weird. It usually works.
Is there a hotkey with this?
Lots of hotkeys in this thing, but this is weird. This only works. Darn it. Always. Oh, wait a minute. What is this not doing the measurements? This is weird. Adding some odd stuff that I don't want it to add. Here we have a constraint that says how long it needs to be. Not symmetry point. No, that's not. I want to get the length thing. Oh, it's been a while. Oh, that's the center point. Oh yeah, this is fun. There we go, that's the length. Wow. Holy moly. Okay. Okay, so you tell it you want it 25 millimeters long, so now it becomes 25 millimeter long. And notice that these two are the same, so that one changed with it.
So they're not just parallel, but they're constrained.
Yeah, they're constrained to follow each other, right? And if I don't want that, I will need to remove that little parallel thing. It's basically just saying they're on a different plane, but it basically, if I change one, it should change the other one too. Same over here, there's a vertical one. You can say, oh, I want this to be 50. And again, if these things would work, and if I do this, I should go to the same point. There we go. Why does it work now? Okay, doesn't matter. So as I do this, I will eventually get to an object that's fully constrained, where I have described exactly all the dimensions I want between all the objects in this plane. And once I have that, then I take this out into a filler that will make it into a real 3D object. And then I can take multiple of these sketches together and make a full object and even animate them and see how, for instance, gears would match together and how they would operate together. So I don't know where all there should be a lot of examples in here that I might be able to.
So the dragon, is it distributed as like a set of triangles, like an actual 3D model that's then converted to slices, or like how does this work?
I'm sorry. Okay, so again, when you're all done, you have an object. I'll make an STL out of that, and then I'm going through the same process as always. So this is something I can use for objects that really has nothing to do with 3D printing at all.
But like the artist would have used Blender and did like striped triangles or something, like a actual 3D model of a dragon.
If I'm doing that, yes, in that case, Blender can also export to an STL.
Okay.
But those, so often when you have some objects, you may find that it's too big or too small, and I will go into that in a moment when I open up the slice, and you can actually shrink or make it small or big or whatever. But if I want something that fits particular to like a PCB where it has an exact size, Blender is not really good at assigning that object. And I can't on slicing really control how the distances needs to be, because it will you can distort the object. But if I distort these two objects, I also distort these two objects. I can't move it around once I get into that point. So that's what I need the modeler to do. But once it's created, I can make a very big case, and then everything gets necessarily dimensioned up to twice as big.
Is that like a case for an Arduino or something?
This is from Raspberry Pi.
Raspberry Pi.
So that movie you saw up there, my initial idea was I have a Raspberry with a camera, and I wanted to use this thing to take the movie with, and my first print was a disaster. So I just took my Pixel book and set that up beside of it with its camera, and it just did a lapse print of it instead. But eventually I want to use this with a little Pi camera to just make movies out of the prints as they're made. Shoot, sorry, let me see if I can actually get to. Not open it. Yeah, let me see if I can find something. This is one of the libraries that I'm using, so let me see. There should be let me check this file. This one. Oh, this is SCAD, sorry. No, it's not what I wanted to do, but let me show them in here anyway. So I'm not sure how to play the animation in here. I've never seen animation being done with that guy. So that wasn't actually what I want to show. So that I learned something. Oh. Okay. So I'm not sure how you say play, but there must be a way to basically say run something with different parameters and you can see it move. But I don't see it. Anyway, so that wasn't what I want to show. You save these in what format? This is where things get hairy for me, because these are all different programs that came up with their own formats. So let's see.
surprised that they can do Autodesk PWG.
Set up. Well, let me see. So KiCad is what I use to design PCBs with, and electrical designs, and it's all 3D based objects too. Let me see if I can open one of these guys. I don't want to show you finished stuff there. Okay. So all of these things can be broken up into different sketches that can all be extruded. This is what the fillet does. It will create additional layers of them. You can say how much you want to change things. Do that. Here. Oh, wow, it's my 2D cursor. What I have used is the ruler in here often is to see when I have an object to figure out what the constraints are. But I should be able to, oh, there we go, here's the model, here's the sketch. First what we're doing there, that's my sketch. I want to look at that one. I want to look at this one. So here we have, this is the two-dimensional they did, and here you can see all the different constraints about how far things have to be between each other. And you can go in and look at other types of the sketches and see how they are constructed, and they're all then put together as one object when they're all done. And it's all based on these parameters you set up as you design. And that makes it possible to make things like this much easier. And there are ways in here to say I want to loop something through 5 times with this degree differences, and it will generate things for you. So if you want to make a screw, you don't have to manually calculate how each of those windings work and all that. So there are ways of creating these things, and that's one of the things for me that's on my learning curve. So I can be more efficient in creating these. I'm pretty good at making boxes, and that's pretty much the layer, the level, and that's what I needed it for initially. But being able to design something like this fast is where I want to go to eventually. So these are all done with replicas and duplications and stuff like that. So they made it once and you just copy them down. So that's the way we design a model. Where I spend most of my time is in the slicing. So, let me actually start the one from Cruiser. Again, I have to cheat because it's not on here normally. So, this version here comes predefined by the print manufacturer with some definition about how the printer works. So it has the printer already in there, and I didn't have to, and again, that was part of what money's worth paying for it, was that they've already tuned it up. So it basically knows how that printer operates, its dimensions, how fast it can go, and so on. I will show you those some of those settings in a moment. But in order to get something done, I can go in and let's say I want to create. So this is my Arduino case, and let's take the nano case for instance. So this is a nano case that I printed. I have stolen this, so this is not my design. It's an old one out there, but Arduino Nano fits perfectly inside of here. You put the lid on it, and you just put power on one end, and it works. And it's pretty easy. You're done, and then you have a little hole here for cables to go out to your whatever lights or whatever else you want to control. So in order to slice this, so all I can do here right now is just view my model, and I go, yeah, that's pretty cool. But the moment I say slice, this means go in and calculate what you need for a 3D model. I can now actually see what the printer is going to see, what the layers are going to be.
Oh, that's cool.
Right? And I can start looking at it at all levels as you go through. So these are actually the individual instructions that the printer is going to get from the G-code as it goes through here. And I can also go up and say, well, I really need to start controlling this better. I need to, for instance, in order to get a very fine model, I need the layer height to be as small as possible. Meaning I'm extruding less at a time, but I can do that at a finer rate. And hence I can't. So It's where you can't rarely see the different layers when you look at the model when it's done. But that it's slow. So another option I have is I can go in and say, when I want to maybe do it much faster at 0.2, it is a little more granular or grainier, but it can print out faster. So if I don't need it very pretty, then I will do that. And actually, I think this was printed with 0.2. So it's not that bad. But I can control that here, and I can change all these parameters. And this is where I start talking about that art form, right? So it starts talking about, well, when you do the vertical shells, how many perimeters do we need? Meaning, how many lines do we need to make on the outside every time to make it robust? And the more lines you do, the more filaments you're using, the more robust it gets. But the more print you're using, the more time it takes. So you want to make as few layers as possible, few extrusions as possible, and still have it robust enough to be used. Some things, like a screw hole, I want to have a lot of support. Other things that is like a little line here, I don't really care because it's not going to hold anything. It's just pretty. Right? So I can control these things and go through. And it also tells me when it starts, it makes 5 solid layers, and then it makes 4 at the bottom. Sorry, it starts with 4 on the bottom and 5 at the top. And again, I can control these, and that's just the layer starting. Right? Whenever there's stuff inside of it, when we have things like, okay, so we have stuff over here. It doesn't really matter. Let's take one of the wheels, for instance. So these are sort of like, they have a thickness to it. Well, we don't want to print stuff inside of it if we can avoid it. If it's empty inside, who cares? But in some cases, we want to eventually make a flat surface on top of it. So if it's all empty, we won't be able to make a flat surface. If there's nothing underneath when we start wanting to print that surface, it won't really work. We call those bridges. And good printers can make very long bridges and be fairly good at it, but it's still pretty, you need a lot of layers to make a good bridge. So we tell it how much plastic to use inside of it to make the infill. And the more plastic we use, the longer it takes, but the better the bridge on top of it we can do. And if it's a big room, it also makes it more robust. It makes basically like a skeleton inside of it that holds everything together. And we can control what kind of fill patterns to use, also to control how we want to have the finish to look, but also how that strength needs to be done, whether it needs to be with grids and so on. And then some of these slicers that are on the commercial side can even customize these once you're done. You can go in and modify it manually if you want to. This guy does all the calculation. You can't modify it once it's done, but I can say what type of grid do I want. And I can start talking about how combining infill. So this is one way of avoiding the printer printing every infill every time, because it's not going to be visible. If it's grainier, it doesn't matter as long as it's there. So I could say, only print the infill every 2 or 3 times. It's enough that the plastic will hit each other and stay put, but it won't really be firm like everything else. So, but it won't then be a good skeleton either. Right? So I have all these parameters I can deal with. I can start controlling. When I start printing, I want to have a foundation for my print that is robust. And that's what the skirt is about. So one thing we start with is usually the printer will always print a test line or something to start the filament flow so it becomes persistent. And often we create a line around the print at a certain distance, and we want to make sure that we at least print, that's what the minimal here is for, a minimal, so we get enough to the extruder so it becomes a constant flow. Because initially when it pushes out, it may not be constant. It may be a blob, or it may be less. So often when I start the printer, initially nothing comes out for the first couple of millimeters. So that just ensures that there's a constant flow.
It's almost like getting the air out of your hose when you turn on the water.
Yeah, something like that. Exactly. Right. So this tells
you
again.
have to tell it all these.
So these are all parameters that you eventually will end up dealing with. The biggest one is the support material.
Did you find it, when you got started, was it a little overwhelming, the learning curve on this? Were you working with other people to help you?
Yeah, without community around this, I would have run out screaming. I wouldn't even have bought the printer. I did back then if it wasn't for community.
Did you see these Radio Shack at one point was selling, little toy printers, but it might be more than what somebody would be able to do.
So I bought I think it was $350 i3 printer. It was not the cheapest one around, but all the guys that was makers said this is a great beginner model, it's not too bad. and it's really hackable. It's easily upgradable. There's a lot of stuff being done that doesn't come from the guy who made it initially to make it better. And I like that. I like being so basically I spent a lot of time printing parts from my printer. When I got it, I thought that, hey, I just turn it on and start printing. And I had no clue what calibration was about. So just the fact of knowing how you actually make the printer tune to, or calibrate so it can actually start printing at all. Right? How do we get the right height in front of me? So one of the first things you have to make sure is first is the level. Right? I have to have the same distance on the front end and on the back end of the plate when I move around. So if there's anything on my frame that is out of whack, and when you build it yourself, that often is what you do, you don't put it together right, and all of a sudden it's all screwed up. And initially I had like 5 millimeter differences between one end and another end, and I go, is that normal? And everyone looked at me and go, holy crap, if it's been half a millimeter, you're off. and I had to figure out what I'd done wrong on the frame, because I literally assembled the thing wrong. But I didn't know that. And it takes a while before, at least for me when I started up, to know that that was just one of hundreds of tuning options that I had.
Are there different things that you can, build or add on to certain printers, like in auto level things?
Yes,
or auto fix stuff?
yes. So there's a BL Touch that was popular a couple of years ago, that can be added to the extruder head, that basically allows the control board to get a signal when it touches the plate. And the BL Touch works with a metal plate. And you can also get basically a metal detector of some kind that you put right where the extruder is, a little offset from it, but very close to it, and almost as close to the plate as it. And it means that when the head hits the surface of the print plate, there's an electric signal that goes to the printer, and that allows you to make a piece of software to basically say, how far can I move the head down before I hit the bed? You move the bed and you try again, and that distance may be very slightly different. It may be a couple hundred steps, because remember, we might have 32, 64 steps per millimeter or something like, or per 0.1 millimeter in there. So it can be a lot of steps, but the printer can now know, if I print on this level, this area of the bed, I need to be in this position to be in the logical position 0, and over here it's a different one, and adjust for that. And that's where the firmware differences come in. Some firmware allow you to do that. Again, that's what I love about the Prusa. The first thing the Prusa does when I turn it on is, while it heats up, I make sure that it's at the right temperature, because it won't do anything unless that happens. And then it moves around the bed in 9 different spots and makes sure that it actually has the right distance in front of it before it stops. And if there's any slight differences from last time, it will adjust itself. And then it starts printing.
I mean, I can see like the gears themselves, like the stepper motors don't move in like fractions of a millimeter, but the gearing can cause it to go very small steps.
Yeah.
And then you have belts that probably get a stretch on them, and like.
But even stepper motors can go very small steps. I mean, an EMA 17 is not a bad stepper motor. In 64.
But I'm saying with the right gear ratios, you can go as fractional as you want to
So
go.
that's what's also happening, right? So you have, in most printers, they would use a what's it called? It's like a band with little teeth on it that moves around. And it's a very small wheel, so it's very close to the ratio of the actual shank from the motor itself. Hence, it's not meant to move very fast, and it can go in small things. But the extruder may go to a very big wheel, or you have a very small wheel driving a very big wheel that then drives the extruder itself, so I can lower the gear ratio and do it even finer. And that is happening, but that's just with the belt, which is the cheap method. Then we have lead screw options, which is almost like what the big boxes do. That is very, very heavy, and it's a real metal rod with a thread on it, and then you have a bolt on it that can screw up and down, and it is very tight to it. But when it turns, it moves up and down. So when the motor turns that shank, it actually it moves it in very small fractions compared to the belt, but it moves very slow.
It's probably more precise.
More precise. So that's actually, and I gotta admit, I've been trying to upgrade my old printer to that for the last year.
But then those kind of things, you gotta oil them and grease them and stuff, don't you? Or
Yes, that was another thing I learned, is to get grease for them, but it's not very often. But yeah, you once in a while you have to grease anything. But I mean, that's with anything that moves around. A very common mistake, people get bearings that are either too cheap, or they put them in wrong, so they start scraping against the rods. And they first put oil on them, but they put them on. People actually have lost the balls inside these bearings because I don't know how they put them in and do that. I have never managed to do that.
Wow.
So much story.
Yeah, and depending on your instructions, they may not tell you how to put in a bearing. The first one I read never just said put the bearings in there. I mean, when you read the Prusa one, it actually says make sure the balls align horizontal with where the load is going to be, like it's going to be up and down, because if we want the balls to actually hit straight on for the bearing to be most efficient. So there's all these little tricks in these guides that says in order to make a printer more stable, you have to look at these little things when you put them together to make it more efficient.
So you're basically scaring me. I don't know if I could start this without a community to.
So this is why there are two options, right? No one says you have to start by building your own printer. And in the Prusa option, the difference is about $150, whether you have them assemble it for you and send it to your hole, or you assemble it yourself. It's not that big of a difference. It's shipping wise, it's a much bigger box, but they assemble it for you. So that may cost you more. But it's a lot cheaper for them to do that. And you can buy a lot of printers, even on the smaller ones, pre-assembled, you just turn them on. I mean, Chuck Mosher is 3D printing, doing that. So he did not assemble his.
But you still have to have some.
The software side, but so some of these professional ones, basically, if you don't need to do very advanced models, you can use the default settings, just hit the slice button and you're done. Or in Cure's perspective, I load the object and hit print, which will first slice it and then print it with default options. And some of them will try to detect when it needs support and automatically turn it on for those things. The problem is that those detections may not always be correct, but in my opinion at least when I've seen them. But they're trying to automate some of it. So you can make basic models. I mean, these things, you don't need to adjust anything. I mean, this is a very basic print.
Not quite at the Star Trek computer, give me a.
No, but it wouldn't take much. We can probably get Alexa to do that. Yeah. Please print me more OpenShift things. Yes, please.
Would you mind opening that video? I'm really curious how you would do this.
Oh, what video? Sorry.
The one I sent you.
In a meetup or?
Yeah, meetup, real quick.
I'm gonna feed the meter.
I'm gonna have to
really
run
curious how to do this, and I have that would be what I would want to build. It should just be. It was like a message.
Okay. Look, I don't know if you took a look at this. It's actually a pretty impressive resume. It's fun.
No.
I took a PDF. There's a couple of people I can think of down in the Germantown area that might be interested in somebody doing this summer doing some work, but I'll have to see. Like, I'm not going to tell them. I'll send them the resume and say, I know this kid.
Hold on.
He's a great kid.
Even I just send it to the wrong person.
Okay.
The spectrum. Sorry.
Anyway.
He's very soft spoken.
So just to scare you some more, Rich. Here's the different speeds we can set.
Wow.
And this is a simplified version of it, so that's even worse. Like, if I have multiple extruders, they can all have different characteristics. I can have different parameters depending on what layer I'm doing. Depending on my printer, I may need to have a different layer height. My old printer, I had to always have different layer height in my first layer. And you can control all kinds of things, and as you do experiments, you will find that certain objects need certain settings. So that's just the print settings. This is independent of the printer.
So what I'm hearing is like when you go to print something, it's going to be like at least 2 runs till you get the thing you want the way you want.
If it's a complex model, it's more than that.
Yeah, but I'm saying, but
that
it's not
doesn't
going to
even
just
count
work
the times where the printer fails and you go, holy crap, what happened? And you guess, and then you go, wow.
But this idea of like downloading a model from the internet, going through all the steps and printing it the first time and seeing it is
if
not.
you just
It's
need
almost
someone,
like you plan on, if your project needs X amount of material, you're going to actually utilize X times 3 material to get it. You get your
again, this is prototyping, and that's typical for prototyping. Right? You keep making mistakes, right? And I would say, I have printed more calibration stuff out than anything else. Right? You print out a little cube that is 20 by 20 millimeters, and when you're done, you take your caliper and you measure it. and if you're off half a millimeter, you go in and adjust and print again until it's spot on. And then and you go in and change the firmware code to tell it how many steps to change that, right? So when it says 20 millimeter, it is 20 millimeters.
I've seen a couple things that you can take old plastics and recycle them.
Yes.
Yeah, how well do they work, do you know?
So there's a lot of YouTubes out there that shows you how you can build one on your own. The problem I have is that you need to know your plastics to make them.
Okay.
Right? So if you're buying, let's say you take milk cartons or containers and stuff like that, they're not necessarily pure just PLA or something else, and maybe a multiple different type of plastics. And often when you get recycled plastic, they come from all different kinds of stuff. So you end up, when you mash it all together, these small pieces, it's like lots of different colors, and if you're not careful when you start out, it might even be different plastic types. So when you melt them all together, you get a completely different consistency.
So, but they do work well for like let's say you want to recycle this, and they work well for your old models
You
and stuff?
can, yes. I mean, there's always a loss there, right? So, but I would say if I could find more than that, and that's what, if you have a big print farm, you see that spool? I mean, I see pictures from a lot of people that are in the communities I have, but they have them stacked multiple stacks up to the ceiling. And they literally have the printers in there. I'm saying multiple printers going 24/7.
Yeah, I've seen those.
So even those, they
before.
want to figure out how to recycle. Some people actually printed little drawers you can put in there, so you can use them for storage. You take them out and put screws in there and take them in again. I mean, it was like, I go, well, that's an interesting way, right? But how do you recycle those? So they basically make a grinder up, and it's, you can do that with a simple motor that just keeps grinding things up. And the biggest trick that I see is to make sure you get the right plastic. And then you have the one that creates the actual filament has to be precise enough so your filament gets a persistent thickness. And this is the hardest part that comes around when you buy filament. If your filament is very cheap, and I have made this mistake several times, I go, wow, I can save $20 per roll by doing this. Once you go home and you start measuring that filament within the same meter, measure a couple of places, and you'll find it varies within, let's say, 1/4 of a millimeter, depending on whether you measure on height or width. That's going to have a huge impact on your print, because it means when it moves a little bit of plastic out, it gets a different amount every time.
Yeah.
So you often see prints that people ask, why do I have a missing layer in the middle of the whole thing? Well, your filament was off.
Are there ways that you can print stuff that shave off a bunch of the filament so it evens everything out? Like a pencil sharpener that you can stick your filament to?
So there are little bits you can do. There are printers that have sensors on them, but you can't really you can't add materials that way. Right?
Or no, you just scrape it off so you haven't even you know what I mean?
You will need a lot of force, but you can certainly put something on there with what do you call blades, what do you call it, shaving or zero.
Yeah, like an electric pencil sharpener that's a wider gate, so it couldn't,
I can see you would do that. I mean, if you had two enough tractions on it, it wouldn't be that hard to build, but your precision has to be pretty close to perfect. And you wouldn't be able to deal with too little, you can only deal with too much.
Yeah.
And what often happens is when they pull it out, it might not go as fast all the time. So in some places it gets more than others, and hence it compensates. But it gets more here, but get less somewhere else. So that wouldn't solve that problem.
So unrelated, Peter. A friend of mine's a Boy Scout troop scoutmaster, and they're always looking for Eagle Project ideas. Collecting ABS plastic, all the discarded Legos that exist in the world. There's probably about 1 billion of them.
Oh my God.
How hard is it to convert that to filament so that they can print
All you basically
prosthetics
do
for
is
kids? That would be huge.
That'd be
I
amazing.
mean, if
That'd
you
be a
get the
great-
same plastic,
That's great. On a bunch of different levels. That keeps guys interested in technology, and that's awesome actually. I sent
Can you send me an email about that group in Nova that's doing that? Like just some contact information for them?
Nova Labs. Just search for Nova Labs.
What is it called?
Nova Labs, Northern Virginia Labs,
LAPS?
LEBS.
LAPS, okay. Nova Labs.
Labs, with a lab, like a
Like laboratory.
Oh, labs.
Before we get into this, my time is kind of squishing. Do you mind taking a quick look at that? I sent a link to everybody. So this was on the
The meetup itself.
yeah.
Yeah, I'm gonna let Randy know, 'cause this is a great.
It's the first one, and it's kind of insane. So
So Peter, what's involved in recycling it? So you get a whole bulk
That's
of
what I was
plastic.
trying to get to, but
Okay.
okay.
Are your slides gonna be on the meetups?
I can put them up there, and it's just a deform post.
What is this? That's his video. Ben's video.
I'm just curious if what his opinion is on it, because I have no idea. It's an infinite printer because it has the heated roller, and I have no idea how I would go about building this or setting this up.
Alright, so the trick really, so the X, Y, and Z printer that I'm showing is one, but you actually have one where it's, oh shoot, what's the name of it? Where it's three prongs coming down, and the way you move them, if you move, so you have one motor to control the whole damn thing. And the belts are pretty easily done. So if you move one arm, then it moves over in one direction. So it basically does some calculations. So the way you move it around is very different from the traditional X, Y, and Z. And there are lots of other
Yeah,
types.
because your printer, the nozzle's always like
Yeah,
this, right?
my printer's always like
it just does this.
But this one seems to be also.
But this one looks like it can do layers
Yeah,
on anything.
I've seen printers that can move it around a little bit too.
Very
And I'm
cool.
not sure where
I'd
it
say-
will allow you to print certain things without support. But I would say in most cases, you have to really make some special models before I think that will pay off. In most cases, when you have those issues, you would not use these FDM type printers.
The black belt commercial model I've seen does that and stuff, and
It doesn't look like that one can actually change the angle based on that setup of the extruder. It just looks like the extruder is at an angle on a permanent basis.
okay.
But I mean, it's an interesting way of doing the arm, absolutely. Based on what I can see in the print, it's not very fine, and I would also have guessed that based on the way the arm is set up, that it may not be able to control it as fine as our printers, but it certainly looks like there's less materials there than in our printer.
Is it fast compared to?
Now that I would call that slow, but it's not fast either. I would say
Okay.
much faster. But it also depends on how much you put in on at the same time. What I wanted to show here. It's been a while since I've looked at this stuff. So sorry.
That's what weird to make you selling it. When they collected Legos, I think.
So I've seen a lot of those from the former Middle East or Africa or whatever, because they have a lot of these things, and this is the way they get a material. Yeah, it won't go much on. Let's see, I can fix this sound.
Weird food.
That's right, it's all about sustainable 3D printing and recycling old failed prints to make new filament, saves you time and reduces waste. Let's check it out.
Yeah, I'm gonna talk.
This is what I have a lot of stuff of.
It's not just
Bad
Legos.
prints.
Before we can start recycling,
But I mean,
we sort
Legos,
parts by
we
color
could find
and
a
material.
trillion of them.
Using these
Most
shoe
people have them in
dividers,
their
we
basement
keep
in
parts
bins.
separated and organized. So how much does my print actually cost? To find that out, we'll use a simple equation. We'll multiply the cost of the filament by the weight of the part and then divide by 1,000 to get our print cost. So if Adabot weighs 110 grams, then it only costs $4 in filament to print. And that's pretty good to know. Filament extruders like the Philibot grind plastic mulch and extrude it out, making recycled filament. Before we can start, we'll need to break down the parts. We can crush them down with a rubber mallet and use a canvas bag to keep pieces from going everywhere.
Alright, so this will be a perfect Eagle Scout project. You gotta smash the Legos.
Well, you have to put it through like a shredder like this, right?
Turn them
You
into
gotta
It
shred
actually has to
Legos.
be that small before you can even
Next,
start.
we'll need to sift through the mulch and remove the bigger chunks. We'll gather up the scraps so that we can feed it into the filament recycler.
Shoot the YouTube.
Temperature and extrusion settings vary for material. Our guide on the Adafruit Learning System has all the details. To get a consistent filament diameter, we'll need to let the filament extrude for a while. We'll need to have a good amount of recycled mulch for your first batch. Guide the filament down to the floor and use a fan to cool down the plastic as it coils. Once you have extruded a good amount of filament, use a caliper to measure the consistency of the filament diameter. And then the next project, we'll find out how well the recycled filament prints and compare it to manufactured filament. Thanks so much for watching, and don't forget to like, share, and subscribe for more 3D printed projects for Beta
And
Print.
what I loved is to watch people actually take old scrap yard stuff and make machines like this out of it.
But they were just using like a yard shredder to shred the stuff.
You get, I mean, there's places that actually shows you how to make those things out
Well,
of
they
it.
called it
It's
mulch.
also-
I mean,
So, but sometimes you also have to put a little bit of chemical in there to do it.
right.
But in essence, it can be done. You have to spend energy on getting them done.
I'm
and
saying this is
it's
why it's a good Eagles. They have to collect the Legos. They have to figure out how to shred the Legos.
Mhm.
They have to make contact with people on how to convert it to filament, and then supply that to the groups that print the prosthesis for the.
Yeah. But they will most likely.
It's,
So
it's
the
got
last
multiple
part.
steps.
Yeah.
There's some organization around it. You're going to need people to help you. So it's a
Remember,
perfect-
those guys are already they're basically giving back for free, most of them, right? They don't charge you, but they will be very, very religious about what filament they're using. So you will probably need to start with finding out who would print with custom filament first, before
Well,
you go
I mean,
on.
but so Lego plastic is actually pretty high quality ABS
It
plastic.
is, but depending on how you extrude it, it may not. I mean, that getting it that consistency is not easy.
Maybe
Yeah.
some other quality control procedures.
I'm
in
saying
the
they will most
design.
likely say, if you do
That's
like
not
this,
the
we can use it, right? But they will have their own requirements for what they would print with, right? And some
I mean,
of
it's
these,
even something to investigate. Like you could just
yeah,
have a phone
absolutely.
call or discussion.
But
with
start
somebody.
there. Start with the guys who are going to print and say, if we gave you free recycled filament, would that be something you're willing to print with? And if so, what type would it need to be?
Filament production would be an excellent open source project.
It'd be an excellent. It'd be a great Eagle Scout or Girl Scout Silver or Gold Star thing. I mean, there's just so many like. And one of the things they want to do is try to create something that's sustainable. So once they complete their Eagle project, they want to leave a legacy. So this begins something where people continue to collect Legos and follow the process.
I'm sure there's another thing they could print that's not potentially like if they print something that's, if they could do it themselves and donate it versus getting it exporting the Legos to another company and have them print these incredibly delicate machines that are responsible for somebody being able to walk.
No, I'm saying that the Eagle project would, or the Girl Scout project would probably convert
This-
Legos to filament. That'd be it. Like
This
that would
guy-
be enough.
Is one of the funniest guys
Hi
I've
everyone.
seen
One of
online.
the things that you didn't hear last
He's a
week when
Spanish
my
guy.
batteries died is that
He
this
prints
section
the
of the chassis in here has almost
biggest
no
crap I've
input,
ever seen.
almost no
What's his
wheels,
name on YouTube?
and I did
His
really,
is
really
Ivan
quickly
something
because I
or
wanted
other.
to finish
Ivan
at least
Miranda.
this version
Ivan
of the
Miranda.
chassis,
Okay.
but now the good version of this part has already finished
10
printing,
3D print.
so I
Okay.
will remove
This-
all that is in
This
this
is actually a
section
small
and move
version.
it
In
to
this
the
one, he makes
new
like twice as
And
big.
as I mentioned at the end of the
how big is this
video,
bed that he's
also I
using?
want to add sections in the middle, so
He has a whole series of those
separate
on printer.
all the
This is
parts
really good.
Can
and
he,
the
so
start.
he shows how to make
He makes the whole printer with you.
So
Makes all the mistakes and he laughs at himself as he does it.
how big is the bed?
He can print these boxes in one, so that would be probably 500 by 500 millimeters. My guess would be.
Crazy.
There are lots of these guys out there. There's Thomas Almander and all that stuff that will
I
go
gotta
to
take off.
and deal with. But
Thank you so much. This is
if
really
you want to
great.
have fun and see what people are doing, this guy's nuts.
Send the links to Mark and just read it.
Yeah.
Where my hoodie?
I see you
Yeah.
guys later.
See ya.
Good meeting.
Anyway, so
Super,
these
super.
are all long.
Look,
When we look at all the parts, everything in that printer, that tank is 3D printed, except for the gears. And the Formula One car that I have, one guy printed it out in 1/4 the size of a Formula One car. Way better. He actually made the bearings out of 3D print.
I need to look up this guy. This is can you add this to the meetup group?
Yeah, absolutely. I can put that in there. And I have a ton of 3D guys that I'm following.
If you could add them to the same like that would be wonderful. I have to go, but nice meeting you guys.
Nice meeting
Yeah,
you.
nice meeting you.
Hopefully this was.
You too. Hopefully we can have some really fun Linux projects and some other
But I would
stuff.
say if you really want to get started and don't know what, find a mega club. I know there's some in Maryland. I don't know where.
Okay.
You don't have to go to Northern Virginia, although we don't bite. Start there because usually there are lots of people there that have made the same mistakes that you're going to make, and they can guide you. Particular, some of these guys actually help you build your own printer from scratch, and they will help you get it tuned and ready to go. and printing one. Instead of doing it on your own. I did mine on my own just using online forums and stuff like that, right?
Any details that you have to start your own that you just have like lying around, like your history that has that kind of stuff, that might start a whole bunch of, like if you could just add a couple of your notes to the meetup group, that'd be really cool.
This is, I mean, we used to have our lock meetings here, and as I said, if I could, I will live there.
Cool.
This is science for kids and for adults and everything else, and it's all about making stuff out of wood, out of metals, making your own PCBs, funny stuff. I think that's the active website. That's the one. That looks like a PBS.
Different notebook.
Yeah, but it's almost the same. Like you see young people, very young people, old people teaching young kids, classes and all kinds of stuff. They have old junk, new stuff.
Is that Prussia?
Crucial. P-R-U-S-A. That's the name of the guy who made it. So.
And that's the one that you recommend?
That's the one. To me, right now, this is most likely going to be the best printer of either this year or last year too. The one they came out with, and they have set the standard for a lot of things. What these guys have put into the MK3 for auto tuning and leveling and alerts, I mean, it's on a very cheap. I mean, there's a lot of cool features that were only available on the very expensive printers before. That these guys have made, and the whole idea of just taking this plate out and breaking it and then the whole thing pops off. It's just wow. I mean, I have literally broken plates before because the thing got too stuck, and that's not fun when it's glass. Right? You can't fit glass. So, but yes, I mean, you can look here. You can see all the firmware. They have it all in GitHub, and you can go in and see everything they have gone on, what's in there. Again, if they didn't have this, I wouldn't do it. And there are lots of companies out there that don't do this. And I go, there's no thing.